minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift up, effective. Close motion. New Glenn has cleared the tower.
New Glenn has cleared the tower! Go, way to go!
Pushing 7 good engines. 30 seconds into flight. Engine operating parameters continue to look good at full thrust. Body rate response to nominal. 40 seconds in. End of roll stretch now level. 50 seconds into flight. Continue to see good engine operating parameters. All set for
A clean burn. We're coming up here on max Q, maximum dynamic pressure. This is the hardest point on the vehicle when it comes to the pressures and the speed. We want to see this rocket punch through that max Q.
Seeing
Let's
good
stand
TBC
by.
control, good MR control. 1 minute, 15 seconds in. Now passing Mach 1, New Glenn is now supersonic.
Supersonic! And we can hear the
1 minute, 30
roar
seconds.
rocket pulse.
Engine operating parameters continue to look good at full thrust. Max Q, maximum dynamic pressure. 1 minute, 45 seconds in.
We have passed max
All
Q.
7
The
V4
robot
engines
is
continue to
real.
look good. Body rate phenomenal. Seeing good control on MR and TBC. Acceleration profile phenomenal. Now passing 2 minutes into flight.
BE4 is unreal.
One minute remaining in boost phase.
All right, 1 minute remaining in boost phase. You heard our team say. Then we'll hit MECO, main engine cutoff. That's going to lead to a sequence of events. We will separate the first stage from the second, and that's when the first stage is going to begin its journey back home. We're going to see if we can land the booster separately. Of course, we will get the second stage off and going with the NASA Escapade satellites on board on their way to Mars.
Trajectory continues to look good, seeing good data quality coming down from the vehicle. Body rate response
Great to hear
phenomenal.
that. Good data quality.
All 7 engines continue
Looking
to look
nominal. Next up, MECO, which is main engine cutoff. The cheers are real. You can hear them all the way in here.
good. And we have MECO.
And we have MECO.
And we have good stage set.
We have good stage separation.
And we have ignition on stage 2. Both engine parameters look good.
Stage 2 ignition.
Oh, you see the 2 rockets there?
Body rate stamping out nicely. Both B3U engines look good at the high thrust set point. Body rate responses look good. 3 minutes, 43 seconds into flight.
Great shot. Look at that view.
We have good indication of payload fairing jettison. Both B3U engines continue to look good. Body rate response phenomenal. Seeing good data coming down from both stages.
Great data. We're 4 minutes into NG2.
And you saw their
pressure response
spectacular
on
view
GS2 look good.
down from our
Responses continue to look
GS2.
good.
You see
This is a 9.5 minute burn for GS2. 4 minutes, 25 seconds into flight.
Wow. All right, at 9 minutes is when we're expecting the first stage to touch down on Jacqueline.
Approximately 2 minutes remaining in the GS1 coast.
Thank you again, everybody, for joining us for NG2. So far, a nominal mission.
GS2 is now 320 kilometers downrange, traveling at 2.8 kilometers per second. Trajectory continues to look good on both stages.
Clean separation, clean fairing
right down the middle of the range
jettison.
track. Engine operating parameters on GS2 look good.
Sounds like our GS2 is having a beautiful ride. The NASA Escapade satellites are exposed to space right now. And we've got GS1 coming down for landing
GS2 body
at
rate's
T
nominal.
plus 9 minutes.
One minute remaining in the GS1 coast. Continue to see good data coming down from both GS1 and GS2. Body rates on both stages look good. The E3U engines look good.
Everything looking good, looking nominal.
Seeing good TVC
And
and
Ari,
MR
on this
control
moment
on
coming up
GS2.
is an important one.
Trajectory
It is.
continues to look good.
We're going to relight the BE4 engines for the re-entry
Body rates
burn.
nulling out on GS1. The exo turn is complete.
There you go. It's about 300,000 feet, less than 100
6 minutes,
kilometers
30
up there,
seconds into
coming
flight.
in for a landing on the Jacqueline, 375 miles offshore, waiting for the first time to land
And
Blue
standing by for
Origin's
GS1
new blend
ignition
booster
shortly.
on the Jacqueline.
Continue to see body rates on GS1.
That looks great. We have our booster re-entry burn.
Oh,
All three engines.
no matter what happens next, we have had a good day. This is further than we made it on NG1.
That's right.
See indication of engine ignition on GS1. Continue to see good data from GS1.
About a minute and a
GS2
half
engine parameters look good.
is when we would see,
Confirm engine cutoff on
never
GS1.
tell me the odds, return to Earth.
You
7
see it in
minutes,
kind of
40 seconds
horizontal
into flight.
position. We've got the strakes on the base of the booster, which give it lift. So we
Right.
can basically fly this booster. Of course, we're using the forward fins as well, plus some of our reaction control system to, as well as the gimbling
GS1
on the
now passing
BE4
30% max
engines
Q.
to turn
8 minutes
the rocket
into flight.
accordingly. On here, it starts to tilt
GS1
down.
now halfway
1
in its
minute to
planned
go.
burn. GS1 system,
Less than
GS2 systems
40,000
continue to look
feet.
good. GS2 throttle down complete. Responses look good. 8 minutes, 20 seconds from flight. Standing by for landing burn ignition. And we have landing burn ignition. See 3 good engines.
We've got our booster landing burn.
Engine control looks good.
Of course those clouds are there.
8 minutes, 43 seconds. Legs deployed. Now
A
down to 1
great
engine
shot
burn.
from our booster.
Standing by for touchdown.
Landing gear deployed.
Standing by for touchdown. Touchdown confirmed. GS2 continuing to work. Burn system looks good. Welcome back to the time.
Has returned to its blue origin. Welcome.
GS2 systems continue to operate well with
New Glenn with the one central BE4. Let's wait here for our second stage. It's going to cut off its engine. It's done its first burn.
And we have SECO, GS2 engine cutoff.
SECO 1.
Yeah.
SECO 1 is confirmed, GS2 right down the track.
Damping out nice.
Currently in the coast phase.
We have one for two so far on our two objectives for our second mission of New Glenn. We have landed the booster for the first time ever.
Right.
And next up, in about 20 minutes here, we are going to separate the blue and gold satellites of NASA's Escapade mission.
And we have SECO. Good
SECO is confirmed.
Engines.
So we have a map for you on your screen, but soon we should be back and able to communicate with our ground stations, and we would have a picture for you. Right now, we are under 10 minutes until we're able to deploy Escapade. And if we do that, I mean, what a birthday gift to Dr. Nikki Fox.
And we have good indication of Escapade Blue spacecraft separation.
We do have payload separation confirmed. Go Blue. Second payload coming up, as we mentioned. Just about a couple of seconds more here.
Standing by for spacecraft 2 set.
Oh, beautiful live shot from over 700 miles
gold
in space.
Confirmed.
And gold has separated. Congratulations, Escapade. Both blue and gold have successfully deployed. We have successfully landed the booster, and we have successfully deployed both the blue and gold satellites for Escapade.
Mars, once a warm, watery world with a thick atmosphere. Now, a cold, arid landscape with its atmosphere thinned out. What caused this transformation? Over billions of years, a relentless flow of particles from the sun, the solar wind, has slowly stripped away the Martian atmosphere, causing surface water to evaporate. But how exactly did this happen, and how could it affect future Mars explorers? NASA's new Escapade mission aims to find out. The Escape and Plasma Acceleration and Dynamics Explorers mission is studying the planet's real-time response to the solar wind, helping us understand Mars's climate history using 2 spacecraft in orbit for the first time.
Past missions that we've sent to Mars to understand the interaction of the solar wind with the planet have only been single spacecraft missions. So Escapade gives us what you might call a stereo perspective, 2 different vantage points simultaneously. This will allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it before.
Escapade's twin spacecraft fly in 2 different formations to see how Mars responds to the solar wind in both time and space.
This is the first time that 2 or more spacecraft have worked out a formation in orbit about another planet, in this case Mars.
In the first formation, nicknamed the String of Pearls, the 2 spacecraft chase each other in nearly identical, highly elongated orbits. This allows Escapade to observe rapid changes in the Martian atmosphere caused by sudden variations in the solar wind.
When we have 2 spacecraft crossing those regions in quick succession, we can monitor how those regions vary on timescales as short as 2 minutes up to 30 minutes. Before we had to wait for 4, 5, 6, 7, 8 hours.
In the second formation, the spacecraft have different orbits that are more separated from each other, allowing Escapade to study both the solar wind and the upper atmosphere of Mars simultaneously for the very first time.
We'll have 1 spacecraft in the solar wind so we can measure what's coming in, and then 1 spacecraft closer to Mars. This will help us understand the cause and effect of what's happening when space weather comes to Mars.
Escapade will not only fill gaps in the story of how Mars's atmosphere changed, it will also help us prepare to send human explorers to the Red Planet. For example, Escapade will give scientists more details about Mars's ionosphere, a part of the upper atmosphere that future astronauts will rely on to send radio and navigation signals around the planet.
Understanding how that ionosphere varies will be a really important part of understanding how to correct the distortions in those radio signals that we will need to communicate with each other and to navigate on Mars.
Escapade's work could also help keep future Mars explorers safe.
Atmospheres can provide a shield that protect humans and other assets on the surface from things like solar radiation or intergalactic radiation. So it's important for us to understand how the atmosphere is changing in order for us to know what we have to do to protect humans and other assets we might put on the surface.
In addition to new science, Escapade is pioneering a new way to reach Mars. Previously, spacecraft launching to the Red Planet had to wait years for Earth and Mars to line up. However, Escapade is launching into a unique orbit that loops around a region in space known as L2, roughly 1 million miles away. Then, it'll return and use Earth's gravity to slingshot itself to Mars. This allows Escapade to launch early and wait in space until the two planets are in the right positions. This first-of-its-kind orbit will also make Escapade the only spacecraft to ever pass through a distant part of Earth's magnetotail, before beginning its 10-month cruise to Mars and starting its cutting-edge work there.
NASA's heliophysics fleet is looking at the sun's influence, and with Escapade, we'll now have multi-point measurements at Mars, which will help us have a more comprehensive picture of what's happening throughout the solar system. We need a solar system-wide understanding of space weather in order to protect our technology and our astronauts wherever they go.